Hello and welcome to these talks on amateur radio. My name is Simon, call sign M0SYS, and these presentations are to introduce students to amateur radio. Amateur radio is an interesting and fun hobby that is enjoyed by young and old alike. It teaches people the technical aspects of radio which have real-world uses, from communications with friends, contacting people around the world, disaster and emergency abilities, and science and discovery applications. In these talks I will highlight the history of the hobby, the technical aspects, practical applications, and a brief mention of specific activities which may be of interest. This is just a taster. The hobby is both broad and deep, and the presentation will be split into 3 separate videos. In this first presentation we will cover the history of amateur radio, the war years, the different radio frequency bands and their abilities, modern use of radio and packet radio. First we'll discuss the history of amateur radio, and in places the details are a little hazy or disputed, but in general radio waves as we understand them today were considered to have been hypothesized by a Scottish mathematical physicist called James Clerk Maxwell from his famous Maxwell equations in around 1865, and later proven to have existed by a German physicist called Heinrich Rudolf Hertz in 1888. The discovery of radio waves was then adapted into a communication method in 1890s by Guglielmo Marconi, who was an Italian inventor. During this time there were already amateur wired telegraphers using wired systems to communicate. These started migrating over to the new wireless technology method, using what they used to call Hertzian waves, which was the name used at the time, later to be known as radio waves. As this amateur wireless radio took off in the early 1900s, the amateurs were at the cutting edge of the technology. At the time, consisting of crude spark transmitters which caused all kinds of interference to other forms of radio communication, in particular commercial and military systems. Over time, governments brought in laws to restrict what frequencies different entities could use, thereby preventing interference. In 1912, there were approximately 200 licenses granted for experimentation in the hobby. The following year there was almost 1,000, and in 1914 over 1,600. At the start of World War I in 1914, the UK government suspended all licenses and ordered the dismantling and removal of amateur radio equipment. Despite this, the hobby experienced huge growth, with numbers hitting 6,000 by 1917. In November 1918, when the war had finished, many advances in radio had been made, including improvements in receiver design, which greatly improved their abilities, but it would not be until 1920 that amateur radio licenses and call signs were reissued. At the beginning of World War II, MI5 created the Radio Security Service to monitor enemy transmissions. In order to recruit more people to monitor these enemy transmissions, they approached the RSGB, the Radio Society of Great Britain, who helped recruit members with advanced Morse code skills. These amateur radio operators were then known as voluntary interceptors, and together with the Radio Security Service were incorporated into the Secret Intelligence Service. There were approximately 1,500 amateur radio operators involved in these operations. The voluntary interceptors were intercepting communications from the enemy from their own homes, spread countrywide, and this meant they had great coverage for receiving different signals. It was all conducted under the Secrecy Act, and interceptors were instructed to post their transcripts of any received information to a particular post box address. The posted transcripts were sent to Bletchley Park near Milton Keynes, where a huge operation was undertaken to set up and decode these messages. Bletchley Park was the location of Alan Turing, who is now famous for building one of the very first computers to decode messages during the war, along with the country's most talented mathematicians, scientists and thinkers, all with the goal of cracking the Enigma codes. There is a huge amount of information now available about this, and our radio club has been on a trip to Bletchley Park to learn all about the code breaking. I highly recommend going, and if you were interested in joining our club, I'm sure we'd be able to go again at some point when it's safe to do so. A memorial plaque was displayed at the National Radio Museum at Bletchley Park in 2013 to commemorate their valuable contribution to the war effort. There are groups of frequencies called bands, and these are grouped together based on their properties. Many radio services are allocated to a particular band, maybe even 2 or 3 of them, and amateur radio operators have access to most bands and hence the ability to communicate, taking advantage of their different properties. I'll mention a couple of properties to illustrate this, but this topic could be a lecture all by itself. A few of the most useful bands include the HF or high frequency band, the VHF or very high frequency band, and the UHF or ultra high frequency band. The HF band contains frequencies that will refract and reflect off the ionosphere. This means the signals can bounce around the world and land on parts of our planet that are not visible by a line of sight. HF propagation allows intercontinental communication and enables signals to traverse mountainous geography as well as vast expanses of water or desert where relaying a message is impossible or impractical under normal circumstances. The downside with HF, the lower frequencies do not allow high data rates and generally only 300 baud is used. The other restriction with HF frequencies are that the aerials tend to be very large and restrictive. For a lot of purposes the half-wave design is used, and when the wavelength of HF runs out from 80 meters to 10 meters, you can imagine an aerial length of 40 meters to 5 meters long can be problematic to small properties. With VHF, frequencies represent a middle-of-the-road ability, which allows high data rates around 1200 baud, good distance coverage, albeit line of sight for the most part, and reasonably sized aerials, which can be fitted to buildings, vehicles, and even handheld radios. Finally, for UHF and above, they offer high data rates, including 9600 baud and higher. The higher frequencies are more susceptible to absorption by obstacles, though, and materials, so in cities, buildings, heavily wooded areas, even inclement weather can actually severely hinder or block these signals entirely. Common devices and techniques used today relate to radio. Packet radio technology was adapted for use with mobile phones, Bluetooth and Wi-Fi, the Internet of Things, text messaging, and more. Radio is used for satellite TV and satellite phone communications, as well as GPS signals. Radio is used for communications with ships at sea. We have access to most of these frequencies as amateur radio operators, and we share certain frequency bands with the military, with a voluntary service called RAYNET, and they're amateur radio operators that support the police, ambulance, fire services, etc. The packet radio system consists of a computer, a terminal node controller or TNC, and a radio transceiver. The TNC is a clever piece of equipment that converts the computer information into audio tones to be sent over the air. As part of this process, the TNC packages the information in the form of a frame, commonly called a packet. The construction of the frame is as follows. The frame starts and ends with a flag, so the receiving station knows where the start and the end of the frame is. The flag is followed by an address. This address actually has the sender address, receiver address, and any via information such as the nodes it's passed through or digipeaters, etc. The next section of the frame is the control, and this is an information section that tells the receiving station what the frame is, whether it's a receiver ready frame, a receiver not ready, an information packet, etc. This is followed by the payload or the information itself. Next is the FCS or frame check sequence. When the TNC gets ready to send the frame, it derives a polynomial based on the values of the bit structure of the address, control and information sections. Then it uses a universally known polynomial to divide this known polynomial into the derived polynomial and puts the remainder of this calculation in the FCS. It's then sent to the receive station, and the receive station calculates the value of the derived polynomial and compares it to the frame check sequence. If they are the same, it knows the data is correct and it uses it. If they don't match, it throws it away, knowing that there are errors present. The algorithm is supposedly so good that theoretically you could send frames all day long, every day for 3,000 years, and you might get one error here and there. One of the great features of packet radio is you can connect to other stations and then use that station to connect to another. This allows you to daisy chain stations together to get from one location all the way across to another that wouldn't be possible otherwise. This diagram you see here is from the Comms Prepper YouTube channel, which is an excellent channel for communications, particularly in disaster situations. And as you can see from here, he's trying to get across the state to be a part of a net quite a distance away. And as he connects from one node to another, he can actually traverse the whole state and actually be a part of the net when normally there was no way he could reach them. We'll be demonstrating this on a demonstration shortly from one node to another station. Here I'm going to demonstrate packet radio. So I have a serial terminal application here running, and I have this set up with a TNC, a Cantronics CAM-XL terminal node controller, and that's connected to a Yaesu radio on the 2 meter band. So we get a command prompt from the system. I'm going to press C to connect, and G1ZEK-8. This is a friend's system, and my radio's just keyed up. It sent information out and his system has responded. As you can see here, we're connected to G1ZEK-8 over in Castle Donington area, and it's giving me options of commands I can use now. So these commands here: B for bye if you want to leave, C for connect, J means just heard, so other stations his station has heard. Let's take a look at that. And this will list other stations that his station has heard on the air. What we're going to do is actually connect from his station to my friend Aaron, which is M6PIU, which, as you can see, the other station has heard. So C, M6PIU. So I'm now using my station to connect to another, which then connects to a third, which is out of sight of my radio. So we're now connected to Aaron, and this is daisy chaining from one station to another to extend your range. Now when you daisy chain the signal like this, the message does take time to go from one to another, and each node actually checks the message for accuracy and that it's correct. So you can actually communicate over long distances through many nodes, because each one is just checking and making sure that the message is accurate, so that over time it doesn't degrade and cause a problem. As you can see, when I connected to Aaron, it becomes a bit like a text message. So once we've made the link, it goes into conversation mode, which is where you can text back and forth with messages, and it's being checked for accuracy. As you can see, the messages are transmitted. I imagine it's probably over 10 miles, the whole length of this communication, and it happens almost instantly. And there we go. We give a command to disconnect. We've now disconnected from the node, and we can continue on. Now from this station there are other functions we can do. We can actually check our own mailbox. So we do that, let me clear the screen here, by connecting to MB7UES, that's my station here, -1. This is my mailbox. And obviously it's an instant connection because we're not going out on the air, it's just communicating internally through the electronics to the mailbox. We can see from the message here we've got plenty of space that's still available, so it's not full. And we have two messages numbered 25 and 26. We can use L to list the messages, and here's the two messages here. So this is from my good friend Dave, so we can read the messages by using the command R. We'll read 25, and he's given me a nice big long list of all the things I can talk about during this presentation. And we can read 26. Here we go, and he's kindly said yes, I can. He doesn't mind me recording his mailbox, so that's good. Okay, to leave this, we could press K. We could delete one by pressing K to kill it, or we could leave by pressing B for buy. But first I'm going to press S for send. I'm just going to send him a thank you message. And there we use the /EX to exit, and then we can press B for buy. And that's now left a message on my system here that he can retrieve. Alternatively, we can actually go to his system. Now his mailbox is on G1ZEK-2. We're now going out over the air to connect to his mailbox, and his image there should depict a picture of a house, I believe, or an M for mailbox, but for some reason it doesn't come out correctly. There's a message there, so we can list the messages. And mailboxes are clever. They'll only list messages that are relevant to you. There could be hundreds of messages on there, and you will only see the ones that you have access to for you and your station only. So here's a message that he's left about the talk on packet, so we can read that message. That's great, lovely. Okay, again I'll send him a message. So this is now leaving a message on his mailbox from me. Oh, I can't type today. Oops, there we go. And there we go. So we've left a message there. Now before we go, we can actually press the J again, and this is for just heard messages, meaning any stations within a reasonable time that his station has heard. You'll see there's several stations there, and if I wanted to connect to one of them, I could log into his node and connect to one of those other stations, provided they're on air at the moment. Using this method, by connecting to a station and looking through its just heard stations, you can link from one node to another, to another, to another, and so on, covering vast distances. And with nodes, as I mentioned, they are error checking all the way through. An alternative to nodes is a digipeater, and a digipeater just forwards the message, it does not check the accuracy of it. So with digipeaters, you may end up with a loss of accuracy over time, especially if you're using more than 2 or 3. and that can cause a problem with the message reaching its destination correctly. With nodes, however, each one checks it and then sends it on accurately all the way through. So generally, over multiple hops, you want to use nodes and not digipeaters.
That was the end of the first talk on amateur radio. I hope you enjoyed it, and I'll see you again on talk number 2.